called surds. Right? Called surds. Have you known surds before? Definition. 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 Surds are irrational numbers. Definition. Surds are irrational numbers expressed in root forms. Surds are irrational numbers expressed in root forms. Irrational numbers expressed in root forms. Example: root m, n root p, etc. Example: you have root m, n root p, etc. Right? Irrational numbers expressed in root forms. If I should use numbers, right? If I should use numbers to present surds, you could have numbers such as root 2 as a surd. You could have root 3 as a surd. You could have root 5 as a surd. Please take a look at it. Look at it. When it comes to taking surds, right? A surd is not necessarily the square root of a number. That's not true. You could have the square root of a number. That's not a surd. It's very much possible. For example, if I take something like root 4 being equal to, what's one of root 4? That's one of 4, which is what there? 2. So at this point now, root 4 is not a surd. Why? Because it has what there? A whole number as its answer. If I take root 9, root 9 is equal to what there? 3. Hence, root 9 is not a surd. So what qualifies something to be a surd is not necessarily what there? The square root. The question is that if I take square root of that number now, will it give me the whole number? As in this case now, if I take the square root of a number and it gives you just the whole number, at that point it is not a surd. But if I take square root of 2 and give you 1 point something, take root 3 to also give you 1 point something, take root 4 to give you 2 point something, at that case now, 1, 2, 3 are called what then? Called surds. Are we good? Alright, pick that one. What is this? Let's do basic rules of surds. Let's look at basic rules of surds. Note the following. Note the following. So here's my first rule. Now let's call it the multiplication law of surds. It says this way: if I'm having square root of a number times square root of another number, because of there is square root of what? These two multiplied, and because of there a equal to the square root of a number times the square root of another number, and because of this one here. Number 2, what if the two numbers are the same thing? So what if I take the square root of a number multiplying the square root of that same number? What happens here? This is equal to the square root of what there? A times A, this one there? A squared. Of course, using the idea of indices now, what's the value of the square root? Square root is simply A squared. Square root means sum root by what there? Half. Of course, half times 2 gives you what there? 1. That's 8 by what there? 1. Which equals to what there? 8. Or 8. Right? So here's the concept. Here's the concept. If the square root of a number is multiplying itself, gives what there? That number. So root 8 times root 8 gives you what there? 8. Root 3 times root 3 gives you what there? 3. Root 5 times root 5 gives you what there? 5. That's the concept. The third rule there about surd is this. What if I have square root of A all over square root of B? Just like when we're multiplying, we said if I'm multiplying two terms, they come under the same square root sign and they multiply themselves. Same thing here. If two terms under surds are divided, what happens then now? This one is equal to A all over B. Or you can say this is equal to this, whichever way there. It's So if I have the square root of a numerator all over a denominator, becomes equal to what there? This root of numerator alone, all over what there? Root of what? Denominator alone. I'll give some examples to illustrate this point. Let's start with example 1. Let's say I have root 2 multiplying root 3. This will now be equal to root, we said a times b. So these two multiply each other, becomes 2 times 3. And it's equal to what there? Root 6. And that's the answer. It's that easy. Number 2. Let's say I have root 7 multiplying root 7. We said if two terms, the same terms, surds are multiplying themselves, it gives you that term. So this time gives you what there? 7 without stress. Please note this. Number 3, if I have, let's say, square root of 7 over 25, for instance, how do I simplify this? Well, so this is now equal to, for terms like this, it becomes square root of numerator all over square root of what? Denominator. So it becomes square root of numerator root 7 all over this of denominator root 25. Of course, obviously, this one here is a sum because it's not a whole number, so it gives you root 7. This one here is not a sum, it can be simplified. Once you simplify there, 5. I'm having 5 here. So this gives you root 7.5. That's the basic rules guiding surds. That's the basic rules guiding surds. Alright, next up please. Next up, basic form of a sum. To express a sum in its basic form, right there. To express a sum in its basic form, comma. To express a sum in its basic form. Simply break down the sum to its simplest terms. Simply break down the sum to its simplest terms. Simply break down the sum to its simplest terms. Example. Find the basic form of the following. Example. Find the basic form of the following. Example. Find the basic form of the following. Right. So, solution to this. Solution. Number 1. Having root 50 is equal to. How do you break down a sum to its basic form? Listen up. How do I break down a sum to its basic form? The idea is this. The number you have there, you check if it is divisible by 2 first. Alright? After that, if it is not divisible by 2, try 3. If it's not divisible by 3, try 4, try 5, just like that. If I start with 50 first, let's start with 2. Question is this. Can 50 be divided by 2? Yes. Right? Like this, what gives you 50 there? 2 and what? 25. Abi? So, hence, root equals what there? Root 25 times what there? Root 2. That's the concept. This is now equal to, what's root 25 there? 5 times what there? Root 2. That's now equal to what there? 5 root 2. Mind you, this 5, I'm going to multiply this to there. Why? Because it does not have this whole square root sign. Are we good? So assuming I have it like this, let's say I have root 5 times 2, this one there, root 10. But in this case now, this 5 does not have a square root. What happens now? Place this 5 close to 2, that's all. So this becomes the basic form of the sum. Example 2. If I have root 12, obviously I'm starting with 2. Can 2 divide 12? Yes. 2, I mean. This now becomes what there? Root 6 times root 2. Root 2 is in this basic form. I can still break down 6. Yes? So, just like what we said, when it comes to breaking it down, start with 2. Can 2 divide 6? Yes. How many will be left there? 3. So, hence, root 6 becomes what there? Root 3 times what there? Root 2. This is now root 6. Of course, times another what there? Root 2. That's the concept. So, why I bring down this one again? Why I break down root 12 into root 6 times root 2? I can still break down root 6 to what? Its basic form. It becomes root 3 times root 2. In this case, it becomes equal to square root of 3 times root 2 times root 2 gives you what there? 2. We said if the square root of a number multiplies itself, it gives you that number. Hence, this is now equal to 2 times root 3 gives you what there? 2 root 3. Mind you, don't say root 3 2. That's the correct expression. Because of that, 2 root 3 is the concept. Okay, number 3. I have root 1 1 1 1 1 0 0 1 1 0 0 1 1 0 0. At this point again, you have to be very smart. Which number can I use here? You can start with 2, right? But 2 give me a bulky number. If you give me a bulky number. So if I'm seeing 0 0, what's in mind there? 10 or 100. 100 I mean. 100 adds 2 0. So it's better for me to use what there? Root 11 times what? Root what? 100. You can say you want to use root 2, but to take of time. Just be smart with this, alright? These 2 zeros will give you 100, and that's it. So this is now equal to what there? Root 11 times what? What's root 100 there? 10. This now gives you what there? 10 root 11. Alright, one final number 4. I have root 27. Root 27, of course, 2 cannot divide this. So we use 3 instead. If 3 divides 27, I have 9. So it becomes root 9 times root 3. Of course, 9 times 3 gives 57. But root 9 is not a sum, because root 9 gives you what there? 3 times root 3. Multiply this. 3 times root 3 gives you what there? 3 root 3. And that's the answer. Alright, so this is how you express sums in the basic form. Divide by 2 first, by 3. In complex cases or big example like this, you can't start doing 2 and 3. The number is too big. You have to be wide enough. The number is what? It's actually 100. 2 zeros. That's the concept here. There. Let's look at examples. Similar sums. Similar sums. 2 or more sorts are said to be similar. 2 or more sorts are said to be similar if they are multiples of the same sum. 2 or more sorts are said to be similar if they are multiples of the same sum. So what you do is this, okay? When it comes to looking for similar sorts, we use this idea in solving some complex questions. Well, I'm getting from the very scratch. That's the concept. When it comes to getting similar sorts, here's the case. Like in this example we just did here, we can see that root 12 and root 27 are both similar sorts. Why? Because if I take root 12, in its basic form, root 12 is what there? 2 root 3. In its basic form, root 27 is what there? 3 root 3. What do you observe? Both of them are multiples of what? The same sum. This is 2 of root 3. Here is 3 of root 3. Observe, root 12 and root 50 are not similar sums. Why? Because here's root 2, here's root 3, here's what there? Root 2. So this is a multiple of root 3. This is what there? A multiple of what? Root 2. So they're not similar. So when we say two sums are similar, what does it mean? It means they are multiples of the same sum. Alright, that's like the concept here. I think that's this. Let's do algebra of sorts. Let's do algebra of sorts. Alright, let's do algebra of sorts. When we say algebra, basically, 4 things come to mind, right? We say algebra, basically, 4 things come to mind. What's that? Addition, subtraction, multiplication, and division. So when we say algebra of sorts, I'll just do the addition of sorts, its subtraction, its multiplication, and obviously, finally, its division. Let's combine the first two, addition and subtraction of sorts. Alright, let's do addition and subtraction of sorts. Pick down 2 or more sorts, 2 or more sorts, 2 or more sorts can only add or subtract themselves if they are similar sorts. 2 or more sorts can only add or subtract themselves if they are similar sorts. Example. Simplify the following. Example. Simplify the following. Example, simplify the following. Example, simplify the following. So you can see I'm trying to both add and subtract sorts at the same time. Alright? I'm asked to simplify this. Right? What first can I do? The condition is this. Two sorts can only add or subtract themselves if they are similar sorts. You can now do this. Check if they are similar sorts first. That's the first case. How do you do that? Break it down into what there is basic form. That's the concept. So this now becomes equal to what's root 80? Root 80 becomes what there? This becomes root 40 times what there? Root 2, right? That gives you 80. Plus what's 80? Root what? 25 times what there? Root 2. Minus what's root 18 there? You can use what there? Root 9 times what? Root 2. That gives you 18. Alright. What percent is now equal to? Root 40 can be broken down. Right? What's root 40 then? Root 20, I mean, times what? Root 2. So 2 times 2 gives you 40. Times 3 here. Root 2. Alright, root 40 is this 2 here. Times root 2 is this one here. Plus, next up. This now gives you what's the value here? 5 times root 2. Minus, what's the value here? 3 times what? Root 2. Observe why I use my bracket here. This is now equal to, I can split this one down. This now gives you what there? Root 10 times what? Root 2. That gives you 20. Times, next up, this is multiplying itself. So it gives you what there? 2. We said if a sum is multiplying itself, it gives that number there. That's 2. This is for this one here. Plus, what do you get here now? 5 root 2. I have moved the bracket. Why? It's now in the simplest form. Minus, what do I get here now? 3 root 2. I have it. Still working on this one here. This is now equal to, I can still break down 10. It will become what there? 5 and 2. This now becomes root 5 times what there? Root 2. That gives you root 10. Times again here. Root 2. This one here. Times again here. 2. Plus, next up, I have this as 5 root 2 minus 3 root 2. Work this out. It's now equal to, this one here is now a sum in this Greek form. So it becomes root 5 here. Times root 2 times root 2 gives you what there? 2. This 2 gives you 2 here. Times, this one comes down here. That 2 plus 5 root 2 minus 3 root 2. So I have this. So here's now equal, this now gives you root 5 times 2 times 2, 4, 8. Root 2 times root 2 gives you 2. 2 times 2 is what there? 4. So be careful with this. Plus 5 root 2 minus 3 root 2. At this point now, this one is now in root 4. So root 5 times 4 gives you what there? 4 root 5 plus this one here, 5 root 2 minus 3 root 2. At this point now, they are now in their basic form. So which of them can add, which can subtract? Obviously, this and this cannot add. Why? Root 5, root 2, they are not similar. So which one is similar? This and this. So they can subtract. 5 minus 3 gives you what there? 2. So I'll bring this one back here. That becomes 4 root 5. So I said 5 minus 3. I'm working with these two because they are similar sum. They are both multiples of what? Root 2. So 5 minus 3 gives you plus 2 root what here? Root 2. So here's my answer. If you want to factorize 2, you can factorize this. Alright? Factorize this. Bring out 2 from here. Because what there? 2 root 5 plus what? Root 2. Alright? 2 times 2 gives you 4 root 5. 2 times root 2 gives you what there? 2 root 2. Very important. That's the answer to this.